Howdy, AP PreCal. It is Ms. Kosh. This is the third video. We started with learning how to do a polar coordinate, and then we looked at polar coordinates that were unit circle friendly and polar coordinates that are not unit circle friendly. And now we're going to talk about how this relates to complex numbers. Okay, so a complex number can be written in the rectangular form a plus bi. And graphs, I've heard it called the Argon or something. I don't know. I've seen that in my IB world. I assume that's a real thing. It's in my IB book. I don't know that PreCal is going to talk about it, but it's kind of cool. Okay, so basically they say graph in the Argon plane, or however you say it. And what they mean is we graph where the x-axis is the real number and the y-axis is the imaginary. Okay, and so where the x-axis represents the real component and the y-axis represents the imaginary. Okay, complex numbers can also be expressed in the polar notation, where I'm going to come back to this in a minute. Okay, hopefully I remember. Because if I write this down right now, it has no meaning until I show you what I'm talking about. Okay, so let's say, I'm going to use an example before I come back and then do a summary, so I don't forget, a summary at the end. Okay. So I have the number 1 plus I, which means I go over 1 in the real direction, I go up 1 in the imaginary direction, and that can be represented here. This is 1 and this is 1. Okay, so what do we know? Well, we know that this is a 45, 45, 90 triangle. We know that it's 1, 1, root 2. Okay, and so what we can do is we can say, well, if we were thinking of this in the polar world, this is an angle, it's a 45-degree angle. This is pi over 4, so that theta is equal to pi over 4. And the radius would be root 2. Okay, so what we do is we want to be able to write this in such a way where we can expand this out and it gives us the original number that we started with. Okay, and so what it is this is going to be root 2 cis pi over 4, and you're like, Miss Kosh, what is cis? Okay, here's what this is telling us. Mathematicians, like we've said, are inherently lazy, efficient. What we want is r, and sometimes in my IB world, we would tend to write this as r, and then in parentheses, and then say cosine of pi over 4 plus I sine pi over 4. Okay, and so this right in here condenses the cosine c plus I, and then sine s, cis condenses right here. Okay, and so typically in IB we would factor out the root 2, but what I've seen in the PreCal world so far, they don't factor it out. I don't know why. They didn't ask me. But so let's think through, let's work kind of backwards on this one. So I'm telling you that because this is a 45, 45, 90 triangle and the angle is pi over 4 and the radius is root 2, I'm telling you that we can write this as root 2 cis pi over 4, or we could expand this out to saying this is root 2 cosine pi over 4 plus I times root 2 sine pi over 4. Okay, I like this answer because I've been doing it in IB for years, but this answer showed up on some stuff I saw in AP Classroom. So we need to be familiar with we need to know that these two things mean the same thing. But let's think about this. This is root 2 times, well, what is cosine of pi over 4? You know your unit circle, so you know that's root 2 over 2. This is plus I times root 2 times, well, what's sine of pi over 4? It's also root 2 over 2. I didn't save myself enough space. There we go, last parentheses. What is root 2 times root 2? It's 2. What's 2 divided by 2? It's 1. Same idea here. So this is 1 plus I. Okay, so complex numbers can also be expressed in polar notation where r cis theta expands to what I have here. R cosine theta plus r I sine theta, I'm not used to putting the r here. What I'm used to doing is saying r cosine theta plus I sine theta, and doing that out in parentheses. But I saw this in AP Classroom. Okay, let's look at another problem. Let's say they say 6 cis 5 pi over 4. You know what? I'm going to change this because we just did a pi over 4 family problem. Let's change this to 5 pi over 6, just to change it up a little bit. Okay, so where in the world, what are we talking about? We want to figure out what is the corresponding a plus bi. Okay, let's think about it on the graph. So 5, that means we're over here somewhere. and the radius is 6. The angle was 5 pi over 6, which means this leftover angle right here is 30. Here's a 60, and this is a 90. Can you read that? I don't know if you can. Oh, well, you can't read it when I take it? Okay, that's terrible. Anyway, you know what I'm trying to do, hopefully. If opposite the 90 is 6, then that means opposite the 30 is half of that. That's 3. And then opposite the 60 is that times root 3. And since we're in that quadrant, this is going to be negative. Okay? And so what this becomes, here's the real component. So this is a negative 3 root 3. And then this is the imaginary component, so we'd say plus 3i. And so here's your A value, here's your B value. Well, let's say we're not so good at 30, 60, 90 triangles. We can always say this is 6 cosine 5 pi over 6, I changed the problem, plus, how do they write it? They write, oh, is that what they do? I don't know what they do. Okay, I times 6 sine 5 pi over 6. It's the same idea. I'm just used to it slightly differently than what we're seeing. Okay, so that means 6 times, what is cosine of 5 pi over 6? We went over a lot and up a little, so that's a negative root 3 over 2. Plus I times 6 times, okay, we went up a little, was 1/2. And I better get negative 3 root 3, which I do. And I better get positive 3i, which I do. Okay, so in summary, if I have a plus bi, and I'm comparing that versus r cis theta, I didn't save myself enough space, but there you go. Okay, a would be equal to, that's the x component. Well, x always ends up being r cosine theta. The okay, that's the a part. And if you think about this, okay, well, here's what we're looking at. You have your a part, your b part, here's your theta, there's your r. So cosine of theta is a over r, so a is equal to r times cosine theta. We can say that the b value, the b component, now not the I, just the b part, would be equal to r sine theta. And that's why we write this I in here, because r sine theta alone doesn't have an I, but cis does, if that makes sense. Okay, what else do we know? That r is going to be equal to the square root of a squared plus b squared. Be careful, it's not bi squared. That changes things. So just think in terms of the little triangle here. And theta, just like before, is going to be arctan of the b over a, but maybe, or we could say it's equal to arctan of b over a plus pi. So we talked about this in the last video. This will be true if we're in quadrants 1 or 4. Yep, that's not a 4. That is sort of a 4. That's kind of terrible. Okay, and this is what we would need if we were in quadrants 2 and 3. Okay, hopefully that was helpful. I think I give you this to practice. And then more of this. Okay, have fun. Go work hard. Let me know how I can help you.